What if heartbreak and hypertension share the same biology? What if emotional trauma could physically change the blood itself? For centuries, we treated emotional pain as something abstract, psychological, separate from the body. But modern research is revealing something far more unsettling. When stress, grief, fear, or chronic anxiety strike, the brain activates ancient survival pathways designed to protect us from injury. Blood vessels constrict, stress hormones surge, platelets become stickier, clotting pathways activate, and deep within the microcirculation, tiny fibrin webs begin forming, like invisible scars. Not metaphorically, but physically. So in this video, we're going to follow that process from the first stress signal all the way to the smallest vessels in the body. Because the deeper we look, the more it becomes clear that emotional wounds don't just hurt, they leave a biological imprint. Every emotional experience is translated into chemistry. Your nervous system doesn't operate separately from your blood vessels, your immune system, or your circulation. They are one connected system. When the brain perceives danger, whether physical or emotional, it activates one of the oldest mechanisms ever built into the human body, the fight or flight response. In ancient environments, this response kept mammals alive. Blood vessels constricted, heart rate rose, stress hormones flooded the bloodstream, clotting pathways activated to prepare for possible injury. For a short, acute crisis, this was life-saving. But the modern nervous system activates these pathways for entirely different threats. Deadlines, financial pressure, relationship conflict, grief, burnout. And the body reacts to these emotional threats far more literally than people realize. And deep inside every blood vessel is a thin, intelligent lining called the endothelium. It is not passive. It listens to stress hormones. It interprets nervous system signals. It adjusts blood flow moment by moment. And when the emotional stress becomes chronic, the endothelium shifts into a defensive state. Vessels tighten, circulation becomes less flexible, and the blood itself begins to change. Stress doesn't stay confined to thoughts or feelings. It moves into the bloodstream. One of the first things that happens is that platelets become more reactive. And platelets are the tiny cellular fragments whose job it is to stop bleeding. Under normal conditions, they rush to injury sites, stick together, and help form a clot to prevent blood loss. In a true emergency, it's life-saving. But under chronic emotional stress, the body starts behaving as though injury may be imminent, even when there is no physical wound. And stress hormones signal platelets to become more sensitive, more adhesive, and more likely to clump. At the same time, the clotting cascade activates. At the center of this is an enzyme called thrombin, a biological formin that coordinates clot formation. When thrombin becomes active, it converts a protein called fibrinogen into fibrin. Fibrin forms along sticky strands, microscopic fibers that weave together into a mesh. During a real injury, this mesh is essential. But under chronic stress, this clotting system may become partially activated for months. And slowly, fibrin strands begin accumulating inside the microcirculation, which are the smallest capillaries in the body, where oxygen delivery actually occurs. Red blood cells begin moving through terrain that is becoming thicker, stickier, and more resistant. Blood viscosity starts increasing, flow begins slowing, and what started out as protection slowly becomes obstruction. So the body is not malfunctioning randomly. It is responding to signals of danger. And the problem is that modern emotional stress can keep those danger signals running for months or even years. And over time, those invisible webs begin acting like biological scar tissue, quietly interfering with circulation at the microscopic level. And this is where stress begins transitioning from something emotional into something vascular. So can we actually measure this? The answer is yes. Through a blood test, you can literally observe the biological imprint of emotional trauma inside the bloodstream. After the loss of a spouse or severe emotional trauma, cardiovascular risk rises sharply. Heart attacks rise, strokes rise, inflammation rises. And when researchers analyze the blood, they find elevated clotting markers. One of the clearest is von Willebrand factor. It is released by the endothelium to help platelets stick together during injury repair. During severe emotional stress, von Willebrand factor levels rise significantly, even when no physical injury exists. Fibrinogen levels rise too, and a marker called D-dimer often becomes elevated, which is significant because D-dimer is produced when the body attempts to dissolve clots. And elevated D-dimer levels mean the body is simultaneously forming clots and trying to break them down at the same time. A continuous cycle of coagulation, not from a wound, but from emotional stress alone. The most vivid example is Takotsubo cardiomyopathy, or in other words, broken heart syndrome. People can experience symptoms nearly identical to a heart attack: chest pain, shortness of breath, severe cardiac distress. Yet when doctors examine the arteries, they find no major blockages. Instead, the heart muscle itself becomes stunned by an overwhelming surge of stress chemistry. An emotional experience temporarily reshapes the mechanics of the heart. So people under prolonged emotional burden, chronic caregivers, PTSD survivors, often show persistent elevations of inflammatory markers, clotting factors, and stress hormones for months or even years. Heart rate variability, or HRV, the measure of the nervous system's flexibility, often declines. And when HRV drops, the body is losing its ability to shift between stress and recovery. The nervous system loses flexibility, the vessels lose flexibility, the circulation follows. So emotional wounds leave fingerprints inside the bloodstream. And over time, those biological fingerprints begin reshaping the terrain of the entire body. So what happens when this state continues for years? First thing to fail is not usually the large arteries. It's the microcirculation. The capillaries are the microscopic pathways where oxygen and nutrients are actually reaching the tissues. So as fibrin accumulates, blood becomes thicker and resistant. Flow through these tiny vessels begins slowing. Red blood cells struggle to pass, oxygen delivery starts declining, waste products begin accumulating, and the tissues begin starving in the middle of abundance. A person can have blood flow through their entire body and still suffer poor oxygen delivery at the tissue level. The heart may pump harder, blood pressure may rise, and often does, but deep within the microcirculation, flow is becoming obstructed. Cells shift into stress metabolism, inflammation rises, energy production declines, and symptoms that seem unrelated begin emerging together. Fatigue, brain fog, cold hands and feet, hypertension, chronic inflammation, burnout, not necessarily because the body lacks energy, but because delivery itself is starting to fail. Over time, the microcirculation can begin disappearing entirely. This is called capillary rarefaction. Tiny blood vessels close down and vanish. The circulatory network literally shrinks. And the body compensates by increasing pressure. The heart pushes harder against rising resistance. But the tissues downstream still remain deprived. The heart pumps harder while the tissues quietly starve. This is why many people feel exhausted, foggy, cold, and inflamed, even when standard blood work appears relatively normal. Because the dysfunction is happening deep inside the microcirculation, far below the level most conventional testing examines. And the emotional wound has become physiological terrain. So the body is not your enemy. The inflammation, the tension, the exhaustion, the vascular constriction, these may all represent a system that never received one simple signal: the danger is over. A body that continued preparing, continued guarding, continued protecting long after the original wound occurred. And the longer that defensive state persists, the more that circulation itself transforms around it. Which raises the most important question in this series. If stress chemistry can slowly close the circulation, what reopens it? What relaxes the vessels, softens the clotting response, and restores flow back into the microcirculation? The body does possess signals of safety, signals capable of shifting the nervous system out of a chronic defense and back toward repair. One of the most important signals may be carbon dioxide. So in the next video, we're going to explore the hidden world of the microcirculation, the capillary gate, and how stress may silently obstruct flow at the smallest vessels in the body. Because the deeper we look into circulation, the more it becomes clear. The chronic disease does not begin where we thought it did.